All right, so today we are going to do 233 notes. So hopefully the sub has given you each a note sheet and you will need a pencil. So if you do not have those items, make sure you pause this video and go get them. All right, so we're going to start off by recognizing, yes, my voice sounds terrible, but remember, I was sick and I'm slowly getting better, so we're just going to have to deal with it, and we'll just say it's a spooky voice for the spooky season, okay? So let's go ahead and start these notes. So we're going to start with some vocab. So first thing we're going to do is we're going to review. A common factor is a factor that is the same for two or more terms. So if you remember, we discussed what a factor is. So remember, a factor are things that you multiply to get a product, okay? These are your factors, okay? So a common factor, so if I'm looking at the numbers, let's just say 4 and 12. A common factor would be 2, okay? Because 2 can go into 4 and it can go into 12. They have that in common, okay? Just like if you have somebody's favorite color in common. So you and somebody else like the color sparkles, okay? That's something you have in common, which is, great color to have. So I fully support it. All right, so a greatest common factor is kind of just what it sounds like. So this is 2 or more integers is the greatest positive integer that is a common factor of both or all the integers. So depending on how many numbers you have. So for example, the greatest common factor, or you might be hearing it called GCF, of 28 and 42 is 14. That is the biggest number that can go in both 28 and 42. Okay, and remember, factors are numbers that go into another number, what we multiplied. Okay, so, because 14 can go into 28 twice and 42 3 times. So that is the biggest number. So we're going to be looking at common factors using and combining that idea with our generic rectangles that we worked on yesterday. So there are several ways to write the dimensions of the rectangle at the right. So yesterday we had our outside numbers and we were finding the inside. Today we're going to be given the inside and we need to find the outside numbers. Okay? So one thing I want you to recognize is that this side of our rectangle is only broken up one way, and we can see here is 2. Okay, so that means that this is going to be a 1's number, and this is going to have to be something in the 10's. Okay, and that'll make more sense here in a minute. So first, let me break this up. My 1, and I apologize, I'm writing on my computer screen, so it's a little difficult. But you're used to my board, so it shouldn't be an issue. All right, so I got to think about what's one common factor that can go into 120 and 18. That'll give me one number here, and so a 1-digit by 2-digit number, that'll give me both 120 and 18. Okay, well, when I'm thinking about it, I'm like, oh, they're both even, so I know 2 can go into there, both of those numbers. So I have to think about what times 2 gives me 120, because remember, this is showing it's a 2 by something. So when I find the area of this one, I know I did 2 times something to get 120, because remember, area is length times width. So when you're thinking, you should come to the conclusion that, oh, 60 times 2. Okay? Same thing for this box. 2 times what gave me 18? Hopefully you said 9. All right. So that's one way to break this up. 120, 18. Okay. So again, I have to think about what's another factor, a common factor that goes into 120 and 18. Okay. 3. 3 goes into 120 and 18. So this is a 3 by something. So a 3 by what gave me 120. So go ahead and pause and figure out that number. All right, so you should have gotten that missing amount was 40, because a 3 by 40 will give you an area of 120. Same thing here. A 3 by what gave me 18? And hopefully you thought of the number 6. So what we're doing right now is we're finding common factors that go into both of these numbers. So we're working backwards, okay? So 2 is a common factor of 120 and 18. 3 is a common factor of 120 and 18. Find one more number that goes into both 120 and 18. And see if you can solve for this last generic rectangle. So go ahead and pause and see if you can figure that out. Okay, so the number 6 also goes into both of those numbers. So I had to think about 6 times what gives me 120. So when you're thinking, you should have gotten 20. And 6 times what gave me 18, which is 3. So common factors of these two numbers were these right here. These were common factors. Goodness, that looks terrible. I apologize. Common factors. So now that we found common ones, what's the greatest common factor, or the GCF, of 120 and 18? So what was the biggest number that went into those two numbers? Hopefully you can see that that is 6. So out of the common factors, which one was the biggest? 6. All right. So if you wanted to write this out in a multiplication sentence with parentheses, you could have wrote 120 plus 18 is equal to 6 times 20 plus 3. And that makes sense, because if we, and we're going to learn more about the distributive property here in 2, 3, 4, but if we were to take this, we're saying 6 is times 20, 6 times 3, which you can see we did up here, 6 times 20 and 6 times 3. That's where the 120 and the 18 came from. So this is how you would write it if they wanted you to write a multiplication sentence with the GCF. Okay, so you wrote it just without the rectangle. All right. Same thing for here. So you're going to do the exact same thing we just came up with. Okay, so you're going to find a common factor that go into 40 and 32, and then find the numbers that go on the outside. Find a common factor, and then figure out that missing number by solving for area. So go ahead and pause and figure those out. Hopefully you have some of these done. Okay, we're going to start with the most obvious common factor that you really never have to write down, but if some of you did, I just want to show you that technically you can. But generally, this doesn't give us really a whole lot of information, if any at all, so we just kind of usually skip it. But you can say that one is a common factor. So what times 1 gave you 40, 40, and then what times 1 gave you 32, 32. So you can include that one if you want. It's not going to change anything. It's not going to be your GCF. So, all right. Another common factor, you should have had 2. They're both even. So what times 2 gave you 40? You're trying to find this missing side length. Remember, it's area. So hopefully you got 20. And then what times 2 gave you 32? And that's 16. All right, another common factor of 40 and 32 is 4. So what times 4 gave you 40? And that should be 10. What times 4 gave you 32? And that's 8. So you're working backwards. Yesterday, we gave you the 4, the 10, and the 8. Today, we're giving you the 40 and the 32. Lastly, 8 can go into both of these. So what times 8 gives you 40? 5. And what times 8 gives you 32? Which is 4. And remember, these are technically like adding these two up. Because remember, we broke these numbers down yesterday. So, which one is the greatest common factor? So the greatest common factor, hopefully, is 8. Okay, here's your common factors. They're just one-digit numbers that go, or sorry, numbers that go into, not necessarily one digit, numbers that go into the ones we're looking at. So out of those, 8 was the biggest one. So to write that with the sentence, you could write, okay, the 40 plus the 32, where did we get that? Oh, we did 8 times 5 and 8 times 4. And that makes sense, okay? Because this is technically like saying 8 times 9. Because if we add the 5 and the 4, and if we added these, I get 72. So it does always make a true multiplication sentence. Okay. Go ahead and flip to the back. Ethan thinks that 5 times 13 can be found by adding 50 plus 15. Is Ethan correct? So go ahead and try to see if you could solve his logic by creating a diagram. So go ahead and pause, solve this, and then come back. All right, so we're doing 5 times 13. And remember yesterday we broke up by place value. So this is like area of 5 by 10. So that area is 50. And this is a 5 by 3. So that is 15. Well, it looks like, okay, perfect. So Ethan is correct. So he can do 50 plus 15 to find out the answer is 65. Remember, 50 and 15 are called partial products. They are part of our answer, and they are products because we multiplied to find them. All right, if we wanted to write a multiplication sentence with parentheses, we could write what we multiplied when we broke up our numbers. So we did 5 times 10 plus 3. Okay. So go ahead and pause this video and draw a generic rectangle and solve for the product of each one. Go. You would set this first one up is your 1 digit goes on here, and then your 11 and your, oh, sorry, let's do it in order so it's not confusing. So 1, 11. So we'll do it in the same order it's shown. Now, if you put the 7 on the top and cut, did something like this and did 7, 1, 11, that's the same thing, and that's completely fine. I just prefer the 1 digit to be on the side, and that is just a personal preference. So we're going to find the area of each of these boxes. This is a 7 by 1. So that's 7. This is a 7 by 11. That's 77. So 7 times 1 plus 11 is equal to 77 plus 7, which is 84. Next one, it wants you to do 5 times 500 plus 4. Okay, so it broke it up for us. And in that first one, A, if you wanted to change the top to 2 plus 10, you could have done that too. Okay, so 11 is just another easier one to work with. So that's why they kept it 11. But if you were like, no, I like breaking it up by place value, because technically this is equal to 12. So if you wanted to break that up 2 and 10, that's completely fine. I just wanted to mention that real quick. So back to finding area. So we find the area of this box. This is a 5 by 500, which equals 2,500. Watch how many zeros you put. And this is a 5 by 4. And that is 20. So 5 times 500 plus 4 is equal to 2,500 plus 20, which is equal to 2,520. Lastly, it did not break this up, so we're going to do it. 206. It didn't have any tens, so we can just ignore those. You can put a row for 0 if you wanted, but you're just going to get 0, so you don't even need to include it. So this is a 3 by 200, so that is 600. And this is a 3 by 6, so that is 18. So 3 times 206 is equal to 600 plus 18. So that is 618. So in the beginning, it had us work backwards. It gave us the inside numbers, and we had to find the outside and write a multiplication sentence with it. Then we took it from a multiplication sentence to the generic rectangle, so backwards again. All right, go ahead and start working on your 233 homework. Remember that we have it written in your book and on that whiteboard, so there is no excuse. You know when everything's due. Okay, so I don't want to hear, I wasn't told. No, you were. All right, just know that I love and miss you guys so much, and I cannot wait to see you already. All right, have a good day.